Guys, doing this room and not. Let's see. I'm sorry for the noises. Okay, let's overview this room.
I have already completed task one. So I have already completed the first discovery you can do by yourself. Then it covers three parts: enumerating targets, discover levels, and the last touch of is reverse DNS lookup. So will see here in scan ports. We have two type of connection, that is TCP and UDP. So here is thing overview of what types of scan does Nmap covers, and how many ports it carries forward to, that is 6 ports. So I have already answered few questions: which service we use port. You can just Google it. UDP port 53. So it is DNS. How many ports does Nmap consider? 6. Here it is 6 ports. What port state is the most interesting to discover as a pen test? HTTP. What port state? Open port, of course. So we'll go to the task 3, TCP flags. Nmap supports different types of TCP port scan. To understand the difference between these ports, we need to review the TCP header. The TCP header is the first 24 bytes of the TCP segment. The following figure shows how TCP headers as defined in RFC 793. This figure, let's see the 793. This figure looks sophisticated at first, however, it is pretty simple to understand. The first row, that is the first row, we have the TCP port number. Let me see. Uh, RFC will look. The first we have the TCP port number and the destination port number. The first figures will at first, however, it is pretty simple to understand. In the first row, we have the TCP port number and the destination port number. That is this first row. You can see that the port number is 16 bytes. There's no example, but we'll see. 16 bits. Sorry, we have TCP port number. We can see the port number is allocated 16 bits. 2 byte, that is 0 byte. 1 byte is equal to 8 bits, that is 16 bits. Okay, 2 bytes. In the second and the third rows, we have the sequence number and acknowledgement number. Each row has 32 bits, 4 bytes, that is 4 bytes allocated with 6 rows total, making up 24 bytes. 1 2 3 4 5 6, and the last is data itself with 6 rows making up 24 bytes, that is 1 2 3 4 4 into 6, 24 bytes. In particular, we need to focus on the flags that Nmap can set or unset. We have highlighted the TCP flags in red, that is this reserve, next to reserve. Setting a flag bit means setting its value to 1. From left to right, the TCP headers are URG, that is URG is a acknowledgement, PSC, RST rest, sync, fin. So we'll see. URG means urgent flag, indicates that the urgent pointer feed is significant. The urgent pointer indicates that the incoming data is urgent, and the data TCP segment with the URG flag set is processed immediately without consideration of having to wait on previously sent TCP segments. Acknowledgement flag, that is a second one. The acknowledgement flag indicates that the acknowledgement number is significant. It is used to acknowledge the receipt of a TCP segment. PSS, that is push flag, asking TCP to pass the data to application promptly, application layer. That is RST flag, reset flag is used to reset the connection. Another device such as firewall might send it to tier a TCP connection. This flag is also used when the data is sent to a host and there is no service on the receiving end to answer. Sync. Synchronize flag is used to initiate a TCP3, that is three-way handshake, and synchronize sequence numbers with the other host. The sequence number should be set randomly during TCP connection establishment. Fin command, the sender has no more data to send, that is finished. What three letters represent the reset flag RST? Which flag needs to be set when you initiate a TCP connection? First package of three-way handshake, that is sync, I guess. So let's go to task 4. Let's start the machine. It will take time, as it will take time. TCP connection scans works by completing the TCP three-way handshake. In standard TCP connection establishment, the client sends a TCP packet with a sync flag, that is the sync flag. Let me turn off this. Sorry. So we have this three-way handshake, that is the client first send a sync packet, and the server will give sync plus act, and that is the synchronize and acknowledge packet, and the connection established by acknowledgement. Sync flag, and the servers respond with the sync flag if the port is open. Finally, the client completes three-way handshake by sending us sync act. We're interested in learning whether the TCP port is open, not establishing a TCP connection. Hence, the connection is done as soon as its state is confirmed by sending a RST ACK flag. You can instead of sending the ACK command, the Nmap will send RST, that is reset ACK command, to break the connection. You can choose to run TCP connect scan using ST, that is the Nmap ST command. So we'll rest command will, in last, it will just send RST ACK command. It is important to note that if you are not a previous user, sudo or root, a TCP connect scan is the only possible option to discover open TCP ports. In the following WhatsApp packets captured window, we can see Nmap sending TCP packets, that is the TCP packets it is sending with sync flag, that is this sync flag to set various ports number. The port numbers are 80 with various port number 256. So we can see here TCP send command sync flag 256 443 143 8888 590 sync flag. It is all the sync flag, and so on. By default, MM will attempt to connect to the 1000 most common ports. A closed TCP ports respond to a sync packet with RST flag. So we can see here RST flag to indicate that it is not open. This pattern will repeat for all the ports, closed ports, as we attempt to initiate a TCP three-way handshake with them. We notice that the port of 113 is open. That is, we get the acknowledge flag by the server. So it replied with the sync ACK. So if you can see, by 443 the acknowledgement is received. Then 443, oh sorry, there is no 443 packet reply to this. So you can see if you run Nmap and was at the sender, you can see. So we notice that's what is about sync ACK. The Nmap completed a three-way handshake by sending an ACK command. So 113 is sync ACK, and the ACK command is, oh, here it is. The figure below shows all the packet exchange between our Nmap host and the target machine ports 143. The first three packets are the, so here we can see that it is filtered the IP address and TCP port with this command in the search bar of the WhatsApp. So we can see first it sends a sync command, sync to 11443 by this port number, that is the machine, and it server respond with ACK, and then again it sends RST and RST ACK command to break the connection. The first three packets are the TCP packets and being complete. Then the fourth packet tears is down with the RST flags down. To illustrate the ST to TCP connect and the following commands return the detailed list of open ports. So if you can see, let's see if you can do any further. Let me quit this. Let's do the same as shown in the command 10.10.28.70. So you can see these many ports are opened with connected scan. So now that we can use -F to enable fast mode and decrease the number of scan ports number from 1000 to 100. Let's see. You can just put the option anywhere. So as it does not show here, but you can see. So you can see it has scanned the 1000 ports, and here only 100 ports, under 100 ports. 100, that is the 100,000 most common to 100 most common. It is worth mentioning that the R option are also be added to scan the ports in consecutive order instead of random order. So we can see it is in the consecutive order. The option is useful when testing whether ports in the open consistent manner. For instance, when the target boots up. Launch the VM, and we have already done this, I guess. Yeah, the terminal. A new service has been installed on the VM since our last scan. Which port number was closed in the which port number was closed in the scan above? But it is now open on this target machine. Let's see. Let's compare. So we have SSS, SMTP, HTTP. POP3 is new, I guess. So that is the port number 110. Let's put it here. So you get the answer. What is the Nmap's guess about the newly installed service? POP3. So it is the Google answer. So you can see service. Let's see service name. 110 is POP3. Okay. So let's go for task 5 TCP sync scan. Let's first close this machine, terminate, and we'll start our next task machine. Unprivileged users are limited to connect scan. However, the default scan mode is sync scan, and it requires a privilege, that is root or sudo user to run it. Sync scan does not need to complete the TCP three-way handshake. Instead, it tears down the connection once it receives a response from the server. That is the just after the sync is received, it just break the scan. Because we didn't establish a TCP connection, this decreases the scan of the chances of the scan being logged. We can select this scan type by using the SSS command. The figure shown below shows how TCP sync scan works without completing the TCP 3 handshake. As in the previous, we can see we have sync command, and will send RST ACK after receiving the ACK, after sending the ACK command. Let's go for the same. So it is here same as this: first sync, then sync ACK, then directory rest. The following screenshot from the workspace shows the TCP case sync scan. The behavior in this case of the closed TCP port is similar to that of the TCP connect scan. So you can see first it sends sync command, and it received, it didn't receive any. So it received the sync command in port 25, and just after this we just reset the connection by RST. Same in the 80 port, RST sync then RST. To better see the difference between the two scans, consider the following screenshot. In the upper half of the figure, we can see the TCP connect scan ST traffic. Any port TCP port, any open TCP port will require Nmap to complete the TCP 3 handshake before closing the connection. In the lower half of the following figure, we can see how our TCP sync scan, that is SSS command, doesn't need to complete the 3 handshake. Instead, Nmap sends a RST once the syncing packet is received. Just like this. Just like in the filter. So the TCP scan the same as here. So it has compared the figure from the TCP sync scan, that is the first is sent the ACK, then rest ACK, same as there. The TCP sync scan is the default scan mode when running Nmap as a privileged user, running as root or sudo, and it is very reliable choice. It has okay, it's running, and it is very reliable choice. It has successfully discovered the open ports you found earlier with the TCP connected scan, yet no TCP connection was fully established with the target. That is sudo nmap. Let's see nmap first. Let's see without sudo 10.10, sorry, 40.169. So our machine has already started, so we can see we can run the close, and with sudo command the result is same. It's been hanged, I guess. Let's wait for some time. So we are here. So there is any new, that is the IRC port 6667 port service. Let's see speed guide. We have IRC internet relay chat service opened here. I don't know what's happened here. It's been hanged. Let's sudo. So launch the VM now. Servers has been opened installed since the last time we scanned it on the drivers. We use the terminal scan. We can, what is the new port? 6667 IRC internet relay chat. So in this way you can see you can run the nmap sync TCP sync command. So let's go to other tasks, UDP scan. Let's terminate this machine and start the other machine. UDP scan is connectionless protocol, and hence it does not require any handshake for connection establishment. We cannot guarantee that our service listening on a UDP port could respond to our packets. However, if a UDP packet is sent to a closed port and ICMP port unreachable error type 3 code is returned, you can select a UDP scan with using the -SU option. Moreover, we can combine with another TCP scan too. The following figure shows that if we send a UDP packet to an open UDP port, we cannot expect any reply in return. However, sending a TCP UDP packet to an open port won't tell us anything. So it is not responding anything. However, as shown in the figure below, we expect to get a ICMP packet of type 3 destination unreachable and code 3 port unreachable. In other words, UDP ports don't generate any response, are the ones that the nmap will state as open. That is the UDP. If it send a typed error code, that is code 3 type 3, the nmap will output the result at the UDP dash that port is open. In the y-axis capture below, we can see that every closed port will generate an ICMP packet destination unreachable port unreachable. So you can see port destinate a port on reachable, that is it is open. Launching a UDP scan against the Linux server proved valuable, and indeed we learned that the port 111 is open. If you can see 111 is open against this Linux server proved valuable, and indeed we can learn the. On the other hand, Nmap cannot determine whether UDP port 68 is open or filtered. So let's scan with dash su for UDP TCP scan, UDP scan, sorry, not TCP, UDP scan. Let's do our IP 24.1. A new service admin installing service. What is the port? What is the UDP port that is now open? So we can UDP scan is generally slow, not like TCP scan. Not slow but fast. But I don't know why it is taking so long. Let's see the IP 24.1. It is the same. Let's see if we can. So it is recording with our buzz mode. So I guess we should have done that too. Let's do another tab. Let's by just normal user su f and b 10.10.24.1. So we have scanned the 53 port, new port, that is a 53, but the service isn't showing anything. Nmap dash h. Dash f is for fast mode, dash p is for, I think it's purpose, in case verbosity level. Let's see if we can find any service open here. Still scanning 8.73. So we, as we have seen, is already here, that is the port 53. We haven't gained the what service is running, but we can see what it is 6.2%. We'll just answer the 53 port. I'm sorry, 3 port. What went the service port 53 service. Let's see. It's the DNS, but here might be different. Shit. Sorry. Port 53 UDP service. DNS is a UDP protocol, but let's see what we get here. It's 99.99% complete, and it's only 9%. Let's see what we get here. So I have RPC bind. No, domain, that is domain. Oh, it's still the DNS to domain. That's nice. We also get the 68 UTP port filter DHCP port. That is good. Domain. So let's go to the fine tuning scope and performance. You can specify the ports you want to list scan instead of the default 100,000 ports. Specifying the port is intuitive by now. Let's see some example. That is a port F, that is 2280 443 scanning port. The port 12, that is port 121 and 1000 inclusive, that is it will also scan 1 and 1023, while P2225 will scan port between 2020 to 25 inclusive. You can request the scan of all ports by using -p dash, which will scan all 65,535 ports. If you want to scan the most common 1000 ports, add F1 using TCP dash top, using dash top ports 10 will check the 10 most common ports. You can control the scan timing using T0 to 5. T0 is the slowest paranoid, while T5 is the fastest. Paranoid is for. According to the Nmap manual page, there are 6 templates: paranoid, sneaky, polite, normal, aggressive. So we mostly use aggressive and insane. To avoid ideas alerts, you might consider T0 or T1. For instance, T0 scans one port at a time and waits 5 minutes between sending each probe. You can guess how long scanning one target would finish to take to finish. If you don't specify any timing, Nmap uses normal T3. Note that T5 is the most aggressive in terms of speed. However, this can affect the accuracy of the scan result due to the increased likelihood of packet loss. Note that T4 is most often used during CTFs and when running to scan on practice targets, whereas T1 is often used during real engagement where stealth is more important. That is the sneaky one. Alternatively, you can choose to control the packet rate using min rate number, that is the number of packet you want to send in minimum rate. For example, max rate 10 or max rate equals to 10, so that your scanner is not sending more than 10 packets per second. Moreover, you can control the probing parallelization using mean parallelism number probes and mean max parallelism number probes. Nmap probes the target to discover which hosts are alive and which ports are open. Probing parallelism specifies the port of such probes that can be run in parallel. For instance, mean parallelism equals to 11512 pushes Nmap to maintain at least 512 probes in parallel. These 512 probes are related to host discovery and open ports. What is the option to scan all the TCP ports between 5000 and 500? We can specify this 5000 to 55000. I guess I put 10 extra. I can ensure that the Nmap will run at least 64 probes in parallel, so we can just specify mean parallelism and the number just will see equals, we will use equal. Which option would you add to make Nmap very slow paranoid? That is T0. Summary. So this room covers 3 types of scam, that is TCP scam, TCP connect scam, TCP sync scam, and UDP scam. These scan types should get you started discovering running TCP and UDP service on the target source. Option dash p, all ports dash speeds, most common ports. F for most 100 most common ports. R for consecutive order, that is the 1 2 3 4. T4 T5 slow and fast, max rate, min rate, and parallelism. Ensure you have taken notes of all the scan covered in this room. It is time to learn more advanced port scanning technique by joining the advanced ports room. Let's complete this room. You can say in the Twitter too.